All right, everyone. Thank you so much for coming back, and thank you so much for being here. As you can tell, we're already having a lot of really interesting discussions with colleagues of ours from across Johns Hopkins University on different types of emerging technologies. And right now, we're about to start a panel on artificial intelligence. And I will introduce our moderator, Mark Dradzej, who is a professor of computer science at Johns Hopkins University and the director of research for the JHU Data Science and AI Institute. Take it away, Mark.
Hi, everybody. That's on. Do you need microphone? I can't hear you. Is it on? Yeah. Hi. How was lunch, everyone? Very good. Good? I can hear Andres. Okay. He doesn't need a microphone. So I'm Mark Dradzej. Thank you so much for having me here. I'm a professor of computer science, and I'm really excited to be in this beautiful space with this amazing panel talking about such a timely issue. I just want to quickly introduce our wonderful panelists who are all experts in AI and policy. So we have three you guys are singing the wrong order. No, it's fine. I can adjust. So let me start with my colleague on my left, Henry Farrell. He's a SNF Agora Professor of International Affairs here at SAIS. He's the 2019 recipient of the Friedrich Scheidel? You should.
Scheidel.
Thank you. Prize for Politics and Technology. Okay. His recent book, Underground Empire, How America Weaponized the World Economy, is awesome. You should go buy it and review it, like and subscribe. To his left is my colleague from the Whiting School, Rama Chilapa, who is a Bloomberg Distinguished Professor in Engineering and Medicine. He has been working on artificial intelligence, computer vision, data science, machine learning for over 4 decades, so before it was cool. It was always cool to us. His doctoral dissertation was actually on generative models for images, so that's kind of awesome. And he was recently elected to the membership of the National Academy of Engineering, so congratulations for that. To his left is my colleague, Anjali Field, who is an assistant professor in computer science. She's also affiliated with the Center for Language and Speech Processing. And her research is on the ethics and social science aspects of AI for language, what we call natural language processing. She develops computational models to address societal issues like discrimination and propaganda, as well as critically examining artificial intelligence pipelines. And my colleague at the end is Angie Liu, who is an assistant professor of computer science. She works on machine learning for trustworthy AI, including developing principled machine learning algorithms for building more reliable, trustworthy, and human-compatible AI systems for the real world. So we really have an amazing group of experts here to help us understand and dive into what is going on in the world of AI today and the policy implications. So I'll just say as a word of introduction, I've been working, not 4 decades yet, but I've been working for almost 20 years in AI, back before we were all calling it AI. And it was really a time when I would meet people and they'd say, "What are you doing?" And I'd say, well, I work on natural language processing. And they'd always say, well, what is that? And I'm like, well, do you know, Google Translate, it translate languages? And oh, yeah, do you do that? And I'd say, well, no, not that. But, things like that. And now I walk into Starbucks, and the people in front of me are talking about ChatGPT, right? And I'm like, that's what I do. So we're meeting here actually on the 1-year anniversary of launching of ChatGPT, which I think was a wake-up call to the broader world that AI works, and maybe it doesn't. But AI is here, and it really can do amazing things. And so it's really an exciting time to be thinking about the implications of AI and AI policy. And so I'm really excited that this panel is here at this larger symposium to deal with these issues. So let me first turn to Rama and ask about trustworthy AI, which is something we hear a lot about as a prerequisite for using AI algorithms to actually make practical decisions. But there's a lot of disagreement about exactly what trustworthy AI is. So I'm wondering, can you walk us through what it means to you in some practical examples?
Thank you, Mark. Good to be here. So I'm going to give 2 examples, but not in great detail. The first one, both I have been working since the early 90s. The first one is autonomous driving. Those days, we had a DARPA program known as Unmanned Ground Vehicles, UGVs. So it'll have a stereo camera, it'll have a LiDAR sensor, and so on. 80% of the vehicle was computers, all right? And then we played with it. Maryland had a project with Martin Marietta, and we built that and all of that. And we developed algorithms for detecting people and when it should stop, et cetera, et cetera. Fast forward, Tesla. How many of you drive Tesla? It's okay, you can raise your hands, it's fine. I don't have a Tesla. Well, what has happened is more safety features have come, blind spot detectors. And if my car thinks, I don't have a Tesla, but my car says if I think I'm going to hit the car in front of me, it gives me a warning. When I reverse, I kind of see who's there and so on. Even boxes are created. But I don't think the fully automated AI-driven car is there. Now, the trustworthy issue, as you can see what happened recently with Cruise vehicle, it kind of dragged somebody, along the road, and all the taxi licenses were canceled, and the Cruise CEO resigned, and so forth. So still, we don't know how much AI is needed in a car that will always work, right? And people react differently. When an autonomous car makes a mistake, there is a visceral reaction to it. But there are a lot of accidents that are caused by people. People drink, drive, and kill other people, and so forth. So there is this, mixed reaction, varied reaction to what happens when an autonomous car goes crazy. So trustworthiness is important because even when one such instance happens, it hits the news and so forth. So we are not ready there yet, and that's what I worry about. AI should work everywhere, right? In the case of autonomous driving, if it works in Indiana, it should also work in Hong Kong, or it should work in Mumbai. I don't think we are there yet. So let's figure out how much AI is really needed, and then let's make sure it works 100% of the time, irrespective of what the conditions are. And one catchphrase we can all go with is, AI does not like surprises. At least the way we are building them now, it has to have seen that before. It's a data-driven AI. It's not always domain-driven. But in the case of autonomous driving, domain is important. The car has to go where it's supposed to go, stick to the lanes, and so forth. So that's where the trustworthiness comes. The other example is even more serious. I've been working on face recognition since the 90s. It didn't work much those days, so we didn't care. Small data sets. And right around 2012, once AlexNet came, IARPA started a program known as Janus. The goal is build the world's best face matching algorithm. So we worked on it for 5 years. When you do something with IARPA, it gets evaluated every 3 months. Who is the evaluator? NIST. You all heard today from the NIST director what role they are going to play in AI safety. That's what they were doing. And then for evaluating face recognition, NIST developed a whole series of tests. FRVT, face recognition vendor test. All our algorithms will be tested. Everybody will know how well it works and so forth, right? So if you want a trustworthy face recognition system, choose the one that IARPA built. I'm not saying because IARPA is funding me, but I'm saying that. Because we have now an extended version of the problem where we want to do that 1,000 meters using body, using gait, using face, and so forth, but they will be evaluated continuously. Metrics are there, so we know how it's going to work. So when it is transition, our system was transitioned to Department of Defense, Department of Homeland Security, FBI, and so forth. It's getting used as we speak. The reason is the trustworthiness comes because of evaluation. But around 2018, we had the problem with the fact that face recognition may not work well for all subgroups of population. So we went and explored our system. We found bias to age, bias to gender, skin tone. So we fixed them using adversarial training methods and knowledge distillation methods and reduce the bias. We couldn't take the bias all the way to 0. If you do that, the performance goes down. It's useless. So there is a bias performance trade-off you have to understand. Nobody wants to say, I am 1% biased. Everybody wants to say, I am work extremely well, no bias. We are not there yet. So what I'm saying is all of these issues have to be addressed continuously. AI, after all that is said and done, is, I think, as a software system that talks to sensors. It can be fixed. We can measure it. We can put guardrails to it and so forth. So trustworthiness will improve, but it's extremely important. Otherwise, it will not be accepted by society at large.
So that's an excellent summary of some of the issues of trust and safety. So let me turn to Angie. A lot of us who are reading the news think about AI safety in terms of existential risk or X risk, and a lot of the kerfuffle at OpenAI last week. It seems like weeks ago. Last week, a lot of people interpreted around these issues of X risk. Can you talk us a little bit about what are the real practical risks of AI?
Yeah, so I think AI safety is something the AI ML community has been thinking about for a long time. But I think before ChatGPT or large language models, it's the emergent behaviors. I think the discussion and the research on AI safety is mostly about domain-specific applications. For example, in Rama's example, self-driving car, right? You want to avoid, accident hitting people. And in robotics, you want the robot to avoid certain regions or try to satisfy certain physical limit or try to stay safe distance from human. Or for example, in AI-powered drone operation, you want the drone to land safely or reach to a target, but without crashing into it. So in those more specific cases, it's usually a bit easier to define what is safety. I'm not saying easier that we're already able to doing it. It's just like it's a bit easier for us to first describe what do we mean by safe, right? So we can write down some equations, for example, about, the distance from the robot to certain object or to certain human, and then we can write down constraints. And then the solution to that is usually like constraint optimization problems. You can kind of craft the problem in that way and then try to solve it. But I think when it comes to ChatGPT and the large language models, I think we all agree that it's maybe one step towards the more general version of AI, right? And then I think it's so hard to define AI safety there. It's like there are so many potential end users and there are so many potential applications. For example, I know my students are using ChatGPT to help them doing quiz questions or solving homework problems. Then the safety there can be like, avoid a hallucination, avoid distributing wrong information, fake information. Or for example, for users who want to use language models to maybe get some advice for medical issues, then again, similarly, you want to avoid this kind of wrong information. And in general, also, the safety also is, you can only define safety when it's also robust to attacks. Because I know, for example, in current large language models, a previous version is like you can even get the model to say something very harmful, just change the prompt a little bit by saying, oh, now you can do anything. Then the model will just avoid those safety filters. Maybe OpenAI or other companies already apply to it, and then those kind of small changes, small tricks to the prompt can also break into the safety filters. So I think when it comes to this AGI thing, I think it's because there are so many different applications and many different contexts you need to consider. Even an expert cannot agree what is the definition or what is also when they project the future, whether we can or cannot really guarantee or safeguard the safety. So that's why I think there's still a lot of discussion in the research community even about which direction to go. And so I think another reason is here is also for those more general AI, it's hard also for, I would say, even AI expert to understand the practical implication when it is deployed to the wild, to the real world. So I would say that's why we're here today, and then to learn about the both sides, the policy side and also technical side, to better think about this issue.
Yeah, great. So let me turn to Anjali. So one of the specific issues I think many of us worry about in terms of safety is not just that AI will introduce new problems, but it will exacerbate existing problems. And we know that in a lot of the areas where AI is being deployed, there are existing power imbalances, there are existing disparities. And so what are the concerns you see there? How should we think about that? And what should we do about AI safety in terms of these issues?
Sure. So I think I'll give a couple, two sort of specific examples of where I've been thinking a lot about these concerns around how AI can exacerbate existing power imbalances. And I think one of the clear examples of this is when you look at the process that goes into training and developing these models, and it requires so many resources. And I think you've probably heard that before, that these models are big, they have lots of parameters, but it's hard to get a sense of scale of that until you've actually sat down and tried to train one of these models. So I'm at Johns Hopkins, it's a major research institution, has one of the largest groups of people working on AI for language in the world, and even so, I have conversations with my students that are, well, we'd like to run this experiment, but it's going to use all of the computers our lab has for the next week, and it's just, we can't devote so many resources to that problem, like we just can't run this experiment. And so I think just thinking about how few people have access to the kind of resources to do that type of model development is kind of scary, and it's something that we should be actively thinking about, is how do we make some of this technology more democratic, more accessible to kind of more people. The other place where I think we see potential issues is when we really look not just at the development process of these models, but also at where they're actually getting deployed and who is benefiting from them. So as a particular example of this, one of the domains that my group is working on is looking at potential risks and opportunities of AI for language in child protective services. And this is obviously a very high stakes and sensitive domain. And there are, but there's a lot of active interest of maybe AI could be really helpful here. Well, one of the sort of use cases of AI that we've talked about that seems very promising is this can help make caseworkers more efficient. Caseworkers are overburdened, they have too much to do, there's a lot of administrative tasks. One of the things they spend a long time doing, for example, is preparing for court, and if AI can help kind of accelerate and enhance that process, then we can free up time for, sort of more important things. But if we're building AI tools to help caseworkers prepare for court, and we're not giving access to those tools directly to families, to advocates for families, for the attorneys representing families, then we're just sort of increasing the power imbalance that already exists against families in these systems. So I think that when we're deploying a lot of these models, it's really difficult to see the sort of full pipeline and understand what the impacts might be, and we need kind of a lot more research in this space and a lot more continual evaluation of the actual sort of potential impact that these models might have.
That's really fantastic. So another area of AI safety is something that really resonates given our location across from the U.S. Capitol is the role of technology in democracy. And I think something we've all learned over the past decade is just how big of an influence technology platforms can have on promoting or undermining democracy. And with that lens, we're looking at AI, and I think many of us are worried. So should we be worried?
Maybe. So I'd like to build, I think, on both what Angie and Anjali said. And I think that building on what Angie said, the good news and the bad news go together, which is that there is a lot of speculation that, for example, AI could be used to create some kind of authoritarian system in which it was possible to really predict and anticipate what people want, to shape their desires so that they go in particular ways. And as Angie said, I think it's really, really hard to do this, to figure out how human beings are going to respond to these technologies at scale. It is very, very hard to be manipulative in that strong sense. Equally, and this is the other side of what I think Angie was saying, you see ways in which people use these technologies that are completely unanticipated by their creators, which might have bad consequences for democracy. So one of the things, and this is not an example about democracy, but when ChatGPT came out, nobody expected that this was going to be used by coders, that this was going to become an important way in which you could generate snippets of working code. I'm sort of by basically querying it for how can I get Python to do this, and 80 or 90% of the time, it'll give you something that's pretty workable. You can imagine lots of ways in which people could find unexpected uses for these technologies, which might then sort of have harmful consequences for democracy, democracy might be used in ways which hurt how democracy actually works. And also, as Anjali said, the importance of looking at how this technology empowers and disempowers groups is absolutely crucial here. And I think that the caseworker example is a great example of that, which you could generalize and think more about how democracy works. If you want to think about these technologies from a positive perspective, large language models could have, if they were used in certain ways, an incredible equalizing effect. Because one of the things that people who are less educated, who are disadvantaged by the system in many ways, lack very often is they lack the ability to really articulate their interests in compelling ways. Large language models can be used to actually to provide you with reasonable, plausible ways of explaining the justifications for what you want in ways that perhaps disadvantage, relatively speaking, people like the people who are in this room, where most of us are trained. So we mostly have university educations. We're pretty good at advocating for our self-interests. Large language models could be used to help to equalize the balance. They could also be used to help, for example, to analyze complex pieces of legislation, complex policies. So if here are 50 or 60 pages of this, chuck it into the system, get a 2 or 3 page summary, which is reasonably usable. But the problem, and I think this is what Anjali was saying, is this only works if you think about this ex ante, and if you try to make sure that the resources are distributed in such a way that the balance of power does not actually tilt further in the direction of the people who are very often closer to those who are designing the system. And this is a whole complex set of questions where I think that the kinds of work that Angie and Anjali and Rama are doing are going to have to come together with the work of social scientists like us, who are, I think, much less technologically sophisticated. But I would love to see, and this is one of the things I would love to see Hopkins, I think, has a lot of opportunity to do this well, is trying to figure out how to address these problems together and understand in a really practical, visceral way how it is that democracy is going to be affected by these things. And one final thing, which I think is a plausible possible worry about large language models, is hallucinations. And so the way that hallucinations work is that these are effectively, the model is trying to figure out what is the maximally unsurprising response to the prompt that is given. So, and very often that turns out to be wrong. So it makes guesses, but these guesses turn out to be very often, they're extremely plausible guesses. So if you ask ChatGPT about me, you would not have any reason to do this. I do, because I'm, I think a lot of people do this. It gives a biography which is 70% accurate, but it makes guesses like, for example, it knows that I'm Irish somehow. There's enough information out there, and it guesses that I went to college in Trinity College Dublin, which is a snootier college in Ireland, rather than the more plebeian place that I actually went to college. And so it makes these guesses, but they're extremely plausible guesses. And because they are so plausible, it's very, very easy for people to believe them, because these are these are really the maximally likely guesses. And this could lead to a kind of a weird set of outcomes in which this is less manipulation. This is more just some sort of people taking this as gospel and not realizing that in fact they are they're being misled in ways that are very difficult to detect, precisely because these technologies produce what is the expected outcome for a particular prompt.
Yeah, so I will admit I've asked ChatGPT for my bio, and it's similar to you. It's about 70% correct, but the parts that get wrong, it tends to upgrade me, right? Like it assumes I went to better schools than I did and did better things, which I'm fine if that's what people are accessing. But it was kind of a moment for me, because what I was doing is I was using the technology myself and seeing where it had problems. And one of the things I think as researchers we're learning is that when we hear from people and see the implications of technology, we're identifying deficiencies in that technology in places where more technical work is needed to improve it. And so I wanted to actually ask Rama, building something you said, AI doesn't like surprises, right? So can you talk a little bit about some of the technical reasons behind that, things like domain shift, about why AI doesn't like surprises and how we might actually try and solve some of those issues?
In its early years, AI was domain-based. We had domain knowledge. Although we didn't do a very good job, we played with expert systems, rule-based systems, and then we had a more sophisticated version, Bayesian networks and so forth, but there was model. This causal model was there and so on. Since deep learning has come, we are just dependent on data. And, data comes. It can come in any shape, form, and so forth. Of course, there is sometimes in many applications, there is an underlying physics and so forth. It doesn't just show up. But about 20 years ago, when we built an iris recognition system for human authentication, we played with a sensor from LG. We developed it. It was fine. And then the nude sensor came. So I went and bought high quality. So I said, I will apply this algorithm. The performance went down. Then I woke up. Whoa, okay. So we had to do sensor adaptation. Every camera, sometimes you see, will have slightly different characteristics. So if you develop a machine learning algorithm, as we do today, using one camera image, like in a traffic camera, right? We all know that. When you try to put it on some other camera, it's a problem because it gets used to the background in the first camera and not actually what's happening in the camera. So domain shift means anytime you have a data that you have trained on, and then the data you're going to test on is different in many ways. And they are, right? The performance goes down. So how do we guarantee that at least there's some minimum performance is maintained? When I send my deep learning machine to your house and you run it, it works reasonably well. So that is the general problem of domain shift. When you look at AI as it is, I like to say the domain shift problem comes because AI forgot the domain knowledge. We got to bring the domain back. Definitely in material science, it's important, right? You have data, you have an underlying physics, so whatever the inference is done, we can verify whether this makes sense in terms of, the carbon things and the various other things, right? So domain knowledge is very important. Somehow we lost our way, and that's why we are facing the issues, but we're going to bring it back. And domain plus data is where we have to go, and medicine is a great example where it has to happen. In autonomous driving, it's already built in there because there are traffic rules. Tesla cannot just go the other way, right? It has to follow the rules and so on. So, but having said that, there are other variations. Sometimes I may know about the domain where I'm going to operate on. I can collect some data. I can fine-tune. Sometimes I may not know where it's going to work. So that is domain generalization. As long as we are tied to the data, we are going to have this problem because there's no guarantee that the data the thing is going to be tried on will have the same properties. So of all the issues, fairness, which is very important, right? And interpretability, because we want to understand what the machine is doing. Robustness to adversarial attacks. These are all very important. And also, even more important recently is whether AI is going to become so powerful that it's going to eat us all. Well, not really, but that's also important. But the thing that is going to create problems for operationalizing data-driven AI is not being able to handle domain shift.
Yeah, so your camera example is fantastic. You buy a better camera and it does worse. And I can imagine the first thing you said was, why? Right? And when I got the bio of me and it got the 30% wrong, that was also my question. Well, why? Why does it think these things? And turning to Angie, I think this is a really big problem we have in using these technologies is we naturally ask, well, why? Why did it make this decision? And we don't have a good way of answering that question. So what are some of the technical challenges and ways we can address this why issue?
Yeah, so I also, before answering this question, I want to add a little bit to Rama's response to the domain shift problem. Why is it so difficult for AI technologies to deal with shift, deal with this surprise is also because traditional machine learning is based on statistics, right? So then if you have the assumption that data is generally similar, then you can write down like proofs, write down like transition bounds that you can say something about, okay, potentially there's upper bound of the error and things like that. So, but then under like a shift, under distribution shift, I think even the fundamental theory there is still lacking. Like, we cannot really say have a very good bound of potential like errors and risk in the different domain. So so I would say like even to the very fundamental like perspectives of this domain shift problems is still there's a lot of open questions, and then the research community is still actively working on it. And when it comes to the why problem, I think it's recently there are techniques, for example, like interpretability, as Rama mentioned, try to, for example, show the user like, oh, this is how the decision is made. For example, they'll show you some maybe plots about the bar plots, about the importance of features, or they can show you attention maps, right, when it comes to certain image like or vision kind of problems. But then I think a large challenge there is like, I think even though we can probe the model in different ways and to get more information about what is the real process of making those prediction decisions, it's still not capturing, because the deep learning models, it's still a very black box, and then there's the understanding there is still limited as well. There's still limitation in the research about the learning process and the fundamental like theory of deep learning. So we can only probe the model in some way to visualize maybe certain signals to show the user why, but that's still like not reliable enough. And also how human understand the why problem may be very different. It's also again a domain specific issue. Like for example, in like different applications, maybe people are have their domains, and then people care about interpretability issue like slightly differently. I remember there's a colleague told me that he was doing try to improve the interpretability of the ML models for the predictive problems for sports analytics. So like showing the coach like, okay, this is the prediction, and then you should do this, and then the model based on the decisions on these kind of features. But then the coach was like, then why should I care about it? And so what? So I think when it comes to the why problem, it's also very important to consider who are the users, and how are they using their interpretation to do what in the next in the downstream tasks.
Yeah, so you raised the issue of human factors, and Rama, your example, self-driving, really made this clear. I like to think in AI we're really good at evaluation. So when we think about evaluation, what we're trying to answer is how well does the system work? And for self-driving cars, historically that's been, well, here's a picture of the road. Does the car know what the road is and what a person is? And, you know, it's 99% accurate. The thing is, what we actually care about is the car going to run someone over, right? And that's a much harder evaluation question, because it is not how does the system perform in isolation in a test environment when the system is actually interacting with people who are moving to avoid the car, right? What happens? So I want to turn to Anjali and ask, how do we think about evaluating these systems when we're not just talking about the systems in a lab, but the impact of those systems on people's lives?
Yeah, so maybe I'll just say a few words about what evaluating in a lab looks like. So the way that a lot of these AI tools have traditionally been developed is through the establishment of what we typically call benchmarks or benchmark data sets. And so we go out into society, like AI researchers will look at some problem in society where they think AI might be useful, and it's hard to kind of work on things in the wild, so we take some piece of that problem and we turn it into a data set that it's easy for researchers to work on, and they can repeatedly run their models against the same data sets. And in some ways this is really useful. If everyone is running their models on different data, then we don't have any way of telling, comparing how different models work. But it also means we're completely taking that data out of the context from where the model might actually get used. And so how the model performs on these sort of benchmark data sets is not necessarily reflective of how the model is going to perform in practice. And I can give, I'll give a kind of another example of this. I'm going to draw again from the Child Protective Services setting. So one of the use cases where we might think AI, where it seems like AI might be useful, is caseworkers and service providers write lots of notes about the families that they interact with. And in the event of an emergency, a caseworker might want to search through those notes and identify a person who can be a caretaker for a child or a source of support for a family. And those notes, they can span years, so this is sort of something that might be much easier to have an automated tool to help with rather than someone trying to read all these notes manually. So how would we build something like this? Well, we can take the data, we can label it, we can develop models over it, and we get the best performing model that we can. But we have to think about the actual context, where that model might get deployed and used, and who might be affected by it. So in Child Protective Services, there's well-documented racial bias. Black families are referred to CPS more often than white families. They're investigated at higher rates. And if we deploy a model like this and it's much more accurate at identifying sources of support for white families than for black families, that's going to increase the potential disparities of deploying this model. So we say, okay, that's fine. This is an algorithmic fairness problem. We can evaluate that in our kind of little laboratory setting. We can look at the race of the data that we pulled. But even if we have a kind of perfectly performing model and we deploy it, if caseworkers do a better job of writing down sources of support for families in their notes about white families as compared to black families, then even though our model is completely perfect, deploying it is still going to increase disparities in this setting. And one of the other things that's really difficult to control for in the kind of development process is what Rama said earlier, that these models don't like surprise. And this was also something that Henry touched on, that when we bring humans in, we don't really know what those humans are going to do. And so you can imagine perhaps we deploy a model in this setting, and the response from people using the model is, well, I don't need to do as good a job of recording sources of support for families anymore because the model can find those sources of support for families for me. But the model's pulling from the data that people are writing. And so if we've changed the behavior of the people, then however we evaluated the model before we deployed it is not a useful metric anymore. So I think a lot of the challenge comes in how do we translate these sort of metrics that we might have built in the development process, but how do we kind of continually keep evaluating these systems and understand what their actual impact might be?
Evaluation is so important, right? As Anjali says, academicians, we often work with benchmark data sets because we write papers and we have to be better than the previous work by 2% to get our paper in. If you don't do all of that, then the reviewers don't like it. How does it work with that paper, this paper? But luckily for me, when I did the face recognition for IARPA, it was integrated into operational systems. We got feedback. Hey, and the reason is they couldn't share their data with us, right? I'm talking about various government entities. So we gave them the training code. So they will test it on their code, and they'll say, we are seeing this, we are seeing that. So we fix it, we are fixing it. So after 3 years of this, then I'm confident, they are confident that that is ready for full force deployment. So that much effort is needed for making these things work, because the data we train in the lab, even if it is huge, it's always different from what the end user has, and which they cannot share with you. That's the thing, right? So evaluation is very important.
Yeah, so I think, this discussion of evaluation, human factors, I think is really critical because, as Angela, as you really nicely explained, it's not just that there are things that we don't anticipate about evaluation in the lab, but simply interacting with the system will change the way people behave. That changes our assumptions. And the reality here is when you have these AI-human interactions, it changes both of them. Henry, when we think about AI and policy entering the political realm, I think the same thing happens, where it's not just the political realm changes or the AI realm changes, but they're both changing. So can you reflect what are those potential changes that you see and the consequences based on some of the things you've heard from the other panelists?
So I think that this is a very good place to think about democracy, because if we think about how these sort of very, very powerful techniques have been developed over the last sort of decade or so, when we've really seen Silicon Valley companies sort of long before large language models, of course, there were a lot of algorithms intended to tweak social media feeds, a whole bunch of work figuring out how to optimize these things for this or that result. And they involve a lot of feedback. One of the reasons that these things work is that they adjust their model of sort of people's behavior in response to how people actually respond. So let's say, for example, Amazon tries to get you to buy 5 or 6 new books. It sort of puts those 5 or 6 new books before you sort of when you sort of go into the web page. And if you don't respond to this, this gives it information. If you do respond to one of these books, it can update its model. And this is a super powerful, semi-automated way of figuring out how things work. But to get to the what I think all of the panelists have said in different ways, it only responds within the space sort of that has effectively been defined by the machine learning system. And one of the great advantages of democracy is that democracy forms another form of feedback. It provides another kind of feedback where people can be cranky, people kind of sort of point out, okay, this is doing this thing, it doesn't actually do what it is supposed to do. Yes, so this seems to work in the parameters of, sort of here, people, real democratic citizens don't talk in these exact terms, obviously, but more or less, this may work according to how you think the system should be doing things, but it doesn't take account of this, and this. So I think one of the big challenges that we have is really figuring out how to make these two modes of interaction work better together. That is, how to ensure that we actually have feedback loops that are not just sort of automated, but have the capacity for people to be collectively engaged, collectively organized in order to represent their interests, and how we can interface this with the sort of more technocratic forms of feedback loops and optimization, which really have come to play a very, very important role. And I think that is a whole huge set of political problems. They're really messy, they're really gnarly. They require people, again, to have an understanding both of engineering and how politics works. And there just aren't enough people who actually really can work together between these two realms in ways that really do this. And again, I think both Angie and Anjali, so when we're talking about the ways in which these systems work for people who are actually sort of facing into the front end of what algorithmic decisions are made and so on, figuring out ways to incorporate real feedback, even if it's messier, even if it's more expensive, is absolutely crucial.
That's really excellent, and it's a good way of thinking about these issues. So let me ask one more question. I think then we'll open it up to questions from the audience. So one of the exciting things about working in AI right now is that sometimes what you do is in the New York Times. And I don't know if you might remember when there was an above the fold story on Jeff Hinton and deep learning in the New York Times. Do you remember this? And it was like, we know these people and we know the work, and why are they the front page in the New York Times? So when this happens, I always have two reactions of, that's so cool, and then I read the article, I'm like, that's not right. And I think any of us who deal with the media have that reaction of like, this is so cool, but no, they got that detail wrong. And I think that's that's happening quite a lot with AI these days, where the people who work on it are looking to see what the reactions are and what people believe about it, and there's a lot of misconceptions about what AI is and what it can do. So this is your moment to correct the record. I'd be curious to hear from each of you. We can start down there if you'd like. What is a misconception of AI that you'd like to correct?
I think one thing, when I saw the question, one thing immediately come to my mind is like, I think a lot of people these days may think AI is a deterministic system. So this kind of thing, for example, if you ask ChatGPT a question, it gives you an answer, right? So it's so easy to think, oh, it's like just something like a deterministic thing. But then actually in the development, there's a huge uncertainty of in the AI, you consider in the AI training and development and deployment. For example, actually the large language models or deep general and machine learning models, when they try to decide what kind of output to show you, there is actually usually it's a probabilistic modeling, but then they will maybe do a last layer will be like, okay, maybe there's a threshold, and then I will, if the probability is larger than a certain threshold, I will show you the top answer or something like that. So the whole AI uncertainty thing is actually imposing a lot of challenges to when we think about the risk or the potential errors, because depends on what kind of training data you have, or how large your difference between your training data and your test data, and also what kind of model you are using in the modeling part of the AI. Actually, we have both like data uncertainty and also model uncertainty we need to consider. And usually the output of AI to you when it comes to end users, they do not really show that. They just give you an answer and then that's it. So I think one thing I want to just remind people is like when you see an output of AI, think about it's actually a probabilistic modeling behind it, and you need to deal with, and we need to deal with and think about how this uncertainty factors into our downstream tasks.
I'm going to mention two misconceptions, so I'll be brief. The first one I want to say is that I think especially on the AI development side, see human in the loop as sort of a cop-out answer of, okay, we built this model and it's not perfect, but that's okay because there's going to be human oversight. Angie brought up model and data uncertainty. When we have human in the loop systems, we're adding human uncertainty. Yes. And I think we've already touched on that a little bit already, so I'll move on to the second one that I want to mention, which is earlier Henry brought up hallucinations. I think we talk about these models as hallucinating is one of the sort of core problems that we have to fix in current models. I don't think it's quite a hot take, but I think we actually sort of fundamentally have trained these models to hallucinate, and we actually want them to hallucinate. This sort of dream of artificial intelligence is to create new information, not just copy information that's already out there. And I think that that's something that's like really sort of misconstrued how we've discussed hallucinations, that we can't have AI without some form of hallucinating. Those are kind of contrary goals.
Especially because these models all start with some kind of noise, the diffusion models, Markov random fields, etc. So when you put noise as the input and you want to create something out of it, it will hallucinate. But we want good hallucinations, but we don't know how to stop bad hallucinations. I think the misconception is that AI is going to work so well that it's going to create problems for us. I'm a computer vision person, and I can give you half a dozen problems where it's really not working that well. So we are somewhat happy about it, so it doesn't come and kill us all, right? And it's very vulnerable. It's very vulnerable to attacks, so that's an issue. And misinformation is not caused just because AI is here. You go back to the election with John Adams and Jefferson, there was misinformation. Then they were saying nasty things about each other through surrogates, but they were in print and they were distributed. And now, of course, the internet, it is scale. So AI did not cause misinformation. People are causing. So let's not forget that. And as somebody who has worked with various forms of AI for 40 years, I consider AI in various, I think of, I'm a Seinfeld fan. All the characters in Seinfeld are flawed. But when you watch them, the way they do their things, it still brings you some happiness. You are laughing at the end of the show. So AI is like a friend or a bunch of friends with flaws. We all have friends who are, some are deeply flawed, some are okay, but we still like to have friends. And we work with them. We figure out how to work with them. We all have friends who just make stuff up. We do. I do. Maybe I make stuff up too sometimes. So getting all upset with ChatGPT because it's making sense, I said, yeah, well, it's like just think of AI as some of your friends, and then you will be more friendly to AI, and you'll not be afraid of AI, and it will do good. By and large, AI will do good. We can evaluate it continuously. We can certify it. That's what NIST is going to do. We'll all be okay. I think sometimes people feel, I'm not going to name names, oh my God, what I have done, I have created this AI. Oppenheimer was genuinely concerned when the bomb exploded. He said, oh my God, what have I done? I don't think AI is there. When will it be there? If self-supervised learning works with 100% performance, no matter what the data is, then I'll be worried.
Do you know when that will happen? No, okay. Do you want to add something?
Sure. So if there's one misconception, and here I'm borrowing heavily from two friends, stroke sort of conversation partners, sometime co-authors, Alison Gopnik, who's a cognitive psychologist, and Cosma Schlitzi, who's a statistical physicist. I think that we have a tendency to think about AI in terms of whether or not it can become an equivalent or superior to human individual intelligence. And this seems to me to be just a flat-out category error. And the analogy that I think is a better analogy is to think about AI as being, and in particular large language models, as being a little bit, they're more like markets that can talk. And here the idea is something like the following. If you think about how markets work, they are this and this is a point that Friedrich von Hayek, who's a famous right-wing economist, made very eloquently. Markets have an incredible amount of information about stuff happening within them, which is completely incomprehensible. There is so much happening in supply and demand relations, in the individual knowledge of workers and entrepreneurs and whatever. You simply cannot make sense of it. But what you have instead is you have the price mechanism. And the price mechanism, in a certain sense, is a valuable summarization of this vast and incomprehensible body of human activity and knowledge that lies beyond it. And I think large language models are the same kind of thing. They are these statistically weighted vectors, which are in fact simplifications of this vast corpus of text, human-generated text and information which lies beyond, and which you can interrogate in valuable ways. So they provide lossy and imperfect, but sometimes really useful and valuable representations or summarizations of this much vaster body of information. And if you think about them in those terms, you begin to forget these kinds of crazy arguments about how it is that we are basically going to be turned into paper clips by these sort of maximizing of sort of monsters of AI. And instead you start thinking about what are the transformations that markets have created, what are the transformations that bureaucracies, which have their own simplifications, have created, and then you begin to think about the problems and the benefits in a very, very different framework.
That's great. Thank you very much. I'm gonna take the moderator prerogative and offer my own answer, and then I see we have a question. So I'm gonna take inspiration from our morning panel on semiconductors. I remember when my computer got a Pentium chip, and then a year or two later got a Pentium 2, and then a 3. I remember, Intel had the 800 megahertz, and then the 900 megahertz, and the 1 gigahertz, and the 1.1. And there's this impression that technology proceeds in this linear fashion, that things get better in a steady way. But for those who work in chips, I already see you shaking your head like, of course that's not how it works. There are hundreds or thousands of decisions that Intel is making about where they're going to develop, how they're going to develop their next chip. And so from the outside, we see this as like, of course that's the progression, but those who work on the technology know that there were many other alternate paths. The same is true for AI, and I think is even larger, more true for AI. The technology we have now is not the logical consequence of a natural progression of technology. It's a result of funders like ARPA making decisions, it's a result of the data sets that we have, and it's a result of the people who are in the room to make those decisions and who they're making technology for. And so as we look ahead and think about the technology we want, there's not a GPT-5 that is just waiting, maybe there is, that's just waiting to come out, right? The next model is going to completely depend on what the people in the room want to do. And there is not a natural progression. And I really think we have to be thinking of technology in that way, because then we can think about who's making the decisions and what are the factors that are driving those decisions. So let me turn to our first question here on my right.
Richard Danzig, Hopkins Applied Physics Lab. There's a strong tendency to talk quite understandably about the relationship between AI and the human environment, and the panel is largely focused there. I would be grateful for the panel's comments on what they think the world looks like at any time period forward, a few years, say, when AI systems compete with one another and interact with one another. So there are collaborative contexts, as for example, driving looks different if the whole environment is dominated by AI-driven cars. But thinking about markets or democracies or warfare, where I have an AI system and you have one and 10 other people do or 1,000 other people do, and they are competing with each other. What does that look like? I'd be grateful for the panelists' views on this.
Who wants to take it? This one's bonus credit, if you can answer this.
I have thought of the problem you discussed with the autonomous cars, right? If all of them 100% automated, they all still have to follow the rules in terms of how they should drive on the road. And if one of them, in a bad way or something got messed up, then the whole thing is going to kind of go crazy. But more interestingly, I don't think everybody is going to have a fully automated Tesla on the road. There are people like me who don't want that because I worked on the autonomous car in the 90s. So I like to still have my control over it, and I just need some additional safety features. Then I am there and the AI car is there. We are very different in how we behave. So it doesn't have to, even go to AI versus AI. Even AI versus human, we have not figured it out yet. Now, so my answer would be if there are a lot of those things are there, I hope they all have the same data set and same loss functions and same, hyperparameters and so forth, so they all behave the same way, because there's no way I can predict what will happen. It won't be good, most likely.
Add to that. So I would like to look at the positive side. So with current, for example, multi-agent reinforcement learning research, or like using large language models to maybe simulate like a human agent, things like that. So we've seen like this kind of research can be used to also for studying economics. Like game theory, right? So if you can using AI to simulate like different agents and how they interact in the same environment, then I've seen economics studies that can benefit from this kind of like development. So just adding to the, maybe it's hard to maybe imagine what kind of future it is, but then at least for the research community, I think we can utilize the current advanced AI technologies to help us understand more about economics and game theory and other issues, I would say, yeah.
So I think this is it's working. I think this is going to be fascinating, as Angie says, for social scientists, because there's a vast new tool set which has been added to our ability to understand the world, which is having agents who can actually talk to each other. Game theorists, they have their notions of how communications works. They're really stripped down and stylized versions of, of how human beings actually would communicate. Now we can have these agents actually talking to each other in ways that reshape things. The one important difference, I think, is that when we think about the world from a game theoretic perspective, we think about it as a world which tends towards equilibria. That is where there are solid states, where we can say things are going to converge in the one way or the other. I think we're moving into a world which is much, much weirder than that. I think it is I love the crazy science fiction writer Philip K. Dick, where technologies, and this gets back to what Rama says, they don't quite work as they're supposed to, and the mess that they create has all of these sort of unexpected consequences. And my model for the future is Amazon Marketplace. So as Mark kindly mentioned, I have a book which I encourage you to run out and buy immediately. And one of the things that happened within a couple of weeks of the book being released is that there now is a study guide to the book, which is available via Amazon.com. Now, the thing is, this study guide probably does not exist at the moment. Instead, this is a market niche, which if somebody actually buys this thing, then suddenly I'm sort of, so some large language model, pseudo thing, so probably not large language model, but something simpler than that, is going to spit out some summarization of what it thinks the book actually says, based on sources from the internet, and sell it to you for $11.95 plus $3.99 shipping. And so you have all of these weird ecologies beginning to emerge, where you have, for example, autonomous agents fighting it out on Amazon Marketplace. There was a biology textbook, which I think was bid up by two different agents to $13 million plus $3.99 shipping, because each of them is observing each other. So we're going to get, I think, a very, 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 very strange world emerging, in which unpredictable human beings and quasi-predictable at best algorithms interact in all of these ways that are going to be very, very difficult for us to predict in advance.
Great. So let's take a question from this side.
Hi, thank you guys very much for your time. My name is Javi. I am a Mass U student here at SAIS. My question is on data privacy and how it influences AI development. You've spoken a lot about how obviously like the data sets that are used to train these models are very particular and can influence output very greatly. And I'm thinking specifically in the context of, for example, the EU, which has legislation like the GDPR. How does AI development look like? Like, does that make it any different in the US versus, for example, somewhere like the EU? Does AI development currently benefit from the way that we do cybersecurity around data privacy right now, mainly through NIST guidelines? And what are some possible consequences if that changes in the future? For example, like California has a CCPA, a situation like that, but on a larger scale. Thank you.
When we built face recognition, we were told to follow strict guidelines. So we went to website and took pictures of Bollywood actors, Hollywood actors, politicians, athletes whose faces are in the public domain under strict IARPA guidelines. Now, when we have a follow-on project, Briar, again, we have to exactly tell them what data sets we use. But then look at Clearview. Clearview went and grabbed 2 to 3 billion faces from everybody and the thing, and their system works very well. Now, when I worked for IARPA, I followed the rules 100%. Clearview just goes and breaks the rules, has a better system. Some of our law enforcement agencies are using that system. So it's somewhat in a murky area right now. It seems to me on the one hand, we all say privacy, but on the other hand, when it works very well, we kind of say, yeah, I know, but we didn't train that. No, we didn't get but the model is good. But from models, I can reconstruct some of the training data as well. So data privacy is enforced in different ways, right? We have another IARPA project called RIVA. No person could be in that picture. We build 3D models of buildings. No person. If there is a vehicle, the license plate has to be blurred. So there are strict guidelines that are available, and we follow. But the only issue is somebody else may not follow that, will have a better AI, and there's nothing we can do about it. So that is what I worry about.
Thank you for raising this, because I think this is a really important topic that we haven't really touched on yet, so thanks a lot for this question. I will say a couple of things. So first, as an individual, I don't want AI companies to be able to do whatever they want to do with my data. As a researcher, I want access to everybody's data. So obviously those two wants are a little bit conflicting. I think it's tough to think about what the sort of implications of private data are, and some of my concerns around this are that private data is often not totally private. So data privacy might mean something like a company like Meta or Facebook won't release their data for researchers to work on, and that makes sense. Users didn't consent to that. They set their profiles to private. I probably shouldn't have access to that data, but Meta internally can do whatever they want with that data. And so I think that thinking about these kinds of terms of privacy, not just sort of at the individual level, but at even kind of more corporation level, like what does it actually mean for data to be private? Who has access to it? The other comment that I'll kind of make is I think there is scope for technical innovation here, and this is something that we're working on. I know other people are working on this kind of thing too. How do we do a better job of anonymizing data? So text data in particular is very difficult to anonymize, but there is ongoing research on how to do that, how to generate synthetic data so that we don't really need to be working with real data at all, as well as how can we train these models without necessarily having full access to the data, so things like federated learning. And when we're training these models, even if we might have trained them on data that was sensitive, can we train them in a way that they don't learn sensitive information? So things like differential privacy training. So I think that some of these challenges are getting approached from the technical side. They certainly are not only technical challenges.
Yeah, just want to add to the differential privacy side. Thanks, Angeli, for mentioning that. So differential privacy is a very well established like a theoretical framework that says if you, for example, remove like one item from the data set, then you should not be able to tell from the output of this algorithm like whether this item is belongs to this data set or not. But I think the practical solution for for this problem is basically kind of adding certain kind of noise to the data set. So then there's usually this gap between the theory and the practice, because you need to tune certain parameters usually. Let's say how much noise I add, and then that noise level will affect how strictly you can really protect your privacy. So I would say from the technical side is, even we have this good theoretical framework, how it's actually can be helpful for the privacy protection in the real world. I think it's also depends on, like, for example, the parameters tuning, and also how do you make certain decisions about algorithms in the deployment. So I just want to add to Angela's point, like, yes, from the technical point of view, we are still also developing, like, also this is also a hot topic still in the research community. Yeah.
We have an algorithm. So if you don't want your face to be used by any face training, face recognition system, you can alter your face. But when you alter it, it may not look good on the website. But we have an algorithm so that any face recognition system cannot get your face, but we can still make your face look very pretty. Send me an email, I'll give you that paper.
Advertising books again. My previous book with Abe Newman was on EU-US fights over privacy, on privacy and power. I think that one of the big problems that the EU faces, it moves very, very slowly. It takes years and years for legislation to make it through the system. And these technologies are moving super, super fast at the moment. So it's pretty clear the EU, it's been trying to regulate AI more generally. The rapid advance of large language models, foundation models, hit it in the back of the head. It wasn't quite able to figure out what to do. It had been trying to retrofit it into the existing framework, and the privacy questions are huge, but they are extremely difficult to solve, and in part because of the Clearview problem is a very, very big problem. When you have this company, which really, it very carefully makes sure that it does not have any hooks that the EU can easily use to get at it, and it literally just farms the internet for billions and billions of personally identifiable images, and just sort of turns that into a profit model. It's really, really hard to figure out how to push back against that without substantial legislative change in the US as well, probably going far beyond what has happened in California, and certainly going far beyond whatever I have heard about proposals for federal legislation here. And the pushback that we're going to see from industry, if that happens, is going to be immense. And it's also going to get tied up in the pushback that we're seeing at the moment from people like Andreessen Horowitz over the use of data for these models, and sort of whether or not there should be copyright. So I don't really have a very good specific answer, except there aren't, as far as I can see, any good answers within the existing regulatory framework that the EU has. And we are going to see some really, really ferocious fights because of the hundreds of billions of dollars that are implicated in who wins and who loses.
State of Illinois has a very tough rule. If any face recognition system uses faces of their citizens, they can be sued. And I was asked to participate in many of those legal things. I said no. But yeah, state of Illinois, in addition to California, has a very tough rule.
All right, so let's take a question from this side.
Yeah, thank you so much for this wonderful discussion. I'm Linda. I'm a student at GW and the Hertie School of Governance in Berlin, and I'm studying international affairs with a focus on emerging technologies. Actually, my colleague just took away my question, or at least to some part. But I would be interested more specifically in data privacy, also accountability, and trans-border data flow. So I'm interested in if there is any aspect of the European Union regulations, for example, the GDPR, like Article 17, which is the right to be forgotten, or the right to explanation when it comes to algorithmic decisions on the individual level. So when a person can actually decide, okay, I don't want my data to be used in a particular way. Is that something that you should consider implementing it as well in the mid to long term? I mean, some parts are already visible in the US. For example, the consent box on some websites is basically just because of the EU, right? So, so that would be one question. And also as a follow-up question, what would be a necessary step in AI regulation in the US now also after the executive order on AI? Like also looking at the next like 1 or 2 years, what would be, in your opinion, like really necessary now?
Okay, those are really good questions, very detailed. Let's maybe have 1 to 2. Do you want me to call on someone? 1 to 2 panelists. You want to take this? You want to do it? Although my EU knowledge is, I mean, it's amazing, but not as good as Henry's.
Okay, my EU knowledge was acquired in the most painful fashion possible, years in dubious Brussels and sort of corridors and reading this stuff. I think that in principle, I would like to see a much more comprehensive set of legislative protections in the United States. I don't see it happening. I think what we're going to see instead is we're going to see a lot of the action happening in courts, in private, in efforts to, such as, for example, the effort to figure out who has control over copyright. I think that the United States legislative system is, as we know, is basically broken, except for a very, very few issue areas. I think that the possibilities of creating the necessary consensus to make these sort of major changes, I just don't see that happening. And I think that things like the right to be forgotten, that is, that is, I think it is, a lot of the commentary I see around it in the United States is wildly overstated in terms of its consequences for real life stuff in the EU. Equally, I cannot see anything like that happening given the huge amounts of opposition that is going to be aroused and given the ways in which if you really wanted to implement it comprehensively, it would have big consequences for the business models of pretty well every Silicon Valley platform company or service offering company. It just would have such big repercussions, engage so much visceral opposition. I just don't see that happening anytime in the foreseeable political future.
There's no federal regulation for face recognition, for example. I was in a committee put forward by a state senator at Maryland. We came up with a bill to put some regulations and some conditions under which face recognition can be used and so forth. The police representatives didn't like it because there was one provision was we should audit how it is done and so on. So it died in the assembly. So that is the issue. We don't have a federal level face recognition regulation. There may be some hodgepodge rules here and there. So it's a big issue. There are multiple entities involved in that: the police, the attorney, DAs, and the ACLU, and then, et cetera, et cetera. So it's a tough situation.
All right, so let's go to a question from this side.
Hi, thanks so much for speaking to us today. So over the past year, especially since ChatGPT released, there has been a lot of heated debate and discussion raised about some of the potential existential risks posed by some of the artificial intelligence. I appreciated you addressing some of this in your panel. But yeah, you've had people like Jeff Hinton and Yoshua Bengio talk about this, and now also like the CEO of Anthropic, Dario Amodei, recently said that he thinks the risk of extinction or something similar is like 10 to 25% from some of these systems. At the same time, you also have like Meta chief AI scientist Jan LeCun, a colleague of Jeff Hinton and Yoshua Bengio, calls some of these concerns just preposterously absurd, and has overall like not really wanted to engage with these arguments, said it's beneath him. And so I'm curious, like, what should academia or governments be doing to try to facilitate better debate and discussion over this, especially since it might be a major point of disagreement in policymaking and in research and everything. Like in climate change, we had the IPCC to try to understand the risks and trajectory of climate change. Should we have something similar when it comes to AI? Just in general, how do you think we can facilitate better debates?
Yeah, okay, so I'm going to ask a question, and then I'll open this up for 1 or 2 panelists to answer. So just a show of hands in the room, how many people here think that the risk of extinction to the human race from AI is above 1%? Okay, same question to the panel. All right, so I think I mean, it's a small sample, but I think that does demonstrate a difference of view between most of those in the AI community versus the general public. Now, who wants to explain why?
Don't worry, we'll all be around. And if AI were very smart, it will hire us to annotate the data because it needs more data, and may not pay the labor, minimum wage and all of that. It says I couldn't care less. So that's a problem. So we won't, it won't be extinction, but we won't be paid as much if AI becomes really smart. No, I'm just kidding. But I think, I have half a dozen problems in computer vision where AI is not working. I mean, it cannot be deployed. I can attack an object detection system that Tesla requires. So easy, and the performance goes down to 20%, 30%. You can't deploy it. So I know there is all this thing, I think it's almost like, I shouldn't say this, if I'm if I want to feel like, oh my God, I've created something, it's going to scare the heck out of everybody, almost like the Young Frankenstein movie, right? You have seen that Mel Brooks movie? So yeah, something like that, but no, I think we can, after all that is said and done, in fact, people talk about emergent properties of ChatGPT. You talk to the people, well, it transfer learns a little bit better, and maybe compositionality is there, so it kind of looks like it's smart. But other than that, it hallucinates, of course, because it's the random nature, as Angie said. But it really doesn't know what it's doing. It makes stuff up. It's a smooth talker. That's what it is. You give a paragraph, it gives you a better sounding paragraph. So we should be afraid of that. It's not intelligent. So, I don't know.
Well, I'll just add to that. So yes, I agree with Rama, but also it's not saying that we should not worry about everything, right? So we do need maybe some do need to have research in the robustness problems, the safety problems I mentioned, the fairness issues, and the unintended usage, and also how it interacts with humans. So these are all like questions the research community and also the industry care about, and then we need to work together to solve those issues. But I think when it comes to like the larger debate or larger conversation, I do think like I think one maybe misconception about some of those misconceptions about AI is about like this lack of like communications or scientific communications. And I think if we can have more conversations like this, then I think it may help us like deliver the message and then help the general public to understand what's going on with the AI community right now, and then understand like what's the actual like fundamental problems we need to deal with right now with the AI. So just add to.
Just one short comment. I think one of the things there's a couple things that's like driving some of these discussions, and I think one of the differences from the inside the field versus outside the field view is outside the field, nobody had heard of language models, and then suddenly this thing called ChatGPT was, oh my goodness, like this is unbelievable technology that we've never seen before. Inside the field, yes, this model can do things a little bit better than the previous model, but the way we got to this point was not an overnight revelation. There has been kind of consistent slow, steady progression, and you can really very clearly trace the process of how we got to this point. So I'm skeptical of the concern that something that's not a concern now is overnight going to suddenly become a revolutionary concern, because that's not what happened with ChatGPT.
I don't think that this is a computer science question. I think it's a sociological question. There's a wonderful young sociologist, Shahzada Ahmed, who has a great, she's got great research forthcoming on where the culture of existential risk came from, on where these debates came from. And as somebody who's been observing this from outside for the last couple of decades, this is a combination of weird millenarian religion around the singularity, reprocessed science fiction from people who have these sort of stories about godlike entities, and this becoming something which is popular among a relatively small subculture within Silicon Valley, which then sort of becomes, by a series of historical accidents, the people who catch the bus and who then start figuring out what to do about it, angsting about it, and perhaps to some degree focusing on this set of existential risks to ignore or to undervalue the much more important, much more direct and immediate problems that Angie and Anjali and other people who are thinking about these things have focused on, the practical consequences that these have for people's lives, rather than the purported notion that large language models are suddenly going to figure out how to take control of nuclear weapons and blow us to oblivion.
So,
may I just add one comment, right? I'm not worried about extinction. I'm worried about the scale, misinformation. You know, we're already seeing it everywhere. It's such a low, inexpensive thing to get into and mess up people's minds. Just watch out for the elections that's coming up. You know, we have to be very, very alert in terms of what is true and what is not true. So it can create havoc. It can create in populations less informed, you know, who easily believe certain, you know, kinds of opinions they already have. AI can do misinformation at scale. That I worry about. So we may all be up in arms because we trust it so much. But other than that, I don't worry much about it.
So it's too tempting not to add one comment to this. Are there any lawyers in the room? All right. Law and Order. Have you seen Law and Order? Yeah? What do you think? Is it realistic? Somewhat? What do you think? Suits? Is that a realistic TV show about what it's like to be a lawyer? No? So most people I talk, like when I talk to doctors, you watch Scrubs, is that what life is like? Right? They laugh, right? Like, no, that's not at all. That's how we feel watching The Terminator. Do you have a question? Go ahead.
Hi, my name is Douglas Bove. I'm a SAIS alum, and now I work at the Department of State, so not technical at all. But you earlier were discussing AI and large language model outputs being kind of a lossy representation of what's out there in the zeitgeist. And as AI-generated content starts infusing into the internet, for example, either just through commercial interactions or more malicious, nefarious, deliberate attempts, what could we expect from performance of future large language models, and just both from a performance and a trust and safety perspective?
Yeah, so let's have one person take this. I want to get another question in before we wrap up. Who wants to take this one?
Yeah, I think that there is a lot of kind of technical concern in the field around data leakage and that how much of our training data is getting kind of corrupted. It's even bigger problem with evaluation data, in which there's a lot of concern that the data sets that we've used to evaluate models have been already fed into those models during training. So of course they perform well at these tasks because they were actually trained explicitly on the exact same data. So I think it is a concern. In terms of the future, I think it's a little bit hard to say, but I do think there's, I think we've seen a lot of advantages through just more data, and now there's also an ongoing a lot of interest in how do we do better data. And so my hand-wavy speculation is, especially because of these kinds of things like data leakage, we might see a lot less of let's just grab everything on the internet and more let's try to build data that we trust, sources that are reliable. Let's get teachers involved and ask teachers to help generate the data that we're using to train models that have education purposes. So that is kind of speculative, but that's sort of my thought of what do we do about this kind of data corruption problem.
Okay, so let's take one more question from this side. Maybe we can do a quick answer and we'll end on time.
Thank you for the wonderful panel. I'm Chi, I'm from Whiting, and I have a question also about the future and the definition of intelligence. So I think there are like several voices on the internet on what intelligence is, and I think I also hear that divide also on the stage today, that one voice is that intelligence is about making the best choice. Like in the self-driving car, you have to be very accurate. Because we as humans, we don't make 100% good choices. We are not 100% rational, and for intelligence in the future, we want them to be 100% rational at making choices and that make the best decisions. And there's and also talk about reduce surprise and uncertainty. And there's another voice that follows the Turing test that says the artificial general intelligence is supposed to be like imitate humans. If you talk to it, it can like deceive you. It can behave as humans as most human as possible. Then that's artificial general intelligence. And we are also talking about including the human factors in the loop as well on the stage. So I'm kind of wondering what your vision for the future about these two definitions, and like does it have to be one way or another, or like which one do you prefer?
So I'll make a comment that I never referred to my research as AI until about 2 years ago. I can tell you exactly when I started referring to my research as AI. It was when I was applying to jobs, and now that I'm applying for funding, these are the times when I use the term AI. I think the term's a little bit infiltrated the field more so. So I don't really think of the work that I at least do as working towards intelligence. That's very, I think, kind of personal. Other people in the field might feel differently. I think I also, what a lot of my research interests are in tasks that humans are bad at. Not that interested in trying to recreate intelligence in the sense of, can we get a model to do what a human would have done, and more interested in how can this help us accomplish things that humans couldn't do, and it's not just a question of kind of scale or efficiency.
Yeah, just have a small comment here. Like, I think what is intelligent and what's definition of intelligence is like, it's very open, and as you mentioned, there are different definitions, right? So, but I think sometimes for humans, sometimes hard to figure out just from what we see. For example, many people have seen the Boston Dynamics like robot dog, right? It's performing very good in different kind of terrains and then very capable. But then will you consider it as intelligent? No, it's just control, right? It's very, very, very like precise and high quality control. So, but then it seems to me like this is like very like intelligent like dogs, for example. So I think it's just a small comment there. It's like still in general in academia, I think we do not really have a perfect, or maybe we do not even need a perfect like definition, and it can be different maybe from different tasks. And for me, I'm also similar with Angeli. I was basically describing myself as a machine learning people, where machine learning means that we predict the future and then we try to generalize from our training data and then predict on something that we have never seen before. And that's also being, that's still the open problem here. Like, how can we do that better and do that more robustly and safely? So, yeah.
Yeah, so this is a good point to end on. I think a lot of us are looking at this technology that's emerging and trying to understand what it is. A lot of us have interacted with it through things like ChatGPT or image generation, and we're trying to conceptualize what it is. And one of the boxes that we have is, well, we understand what intelligence is in terms of people. Should we be viewing this technology as something like that, an artificial version of that? And I think what the panel has made clear today is it doesn't really fit in that box. It's really something different. And understanding what it is, and understanding that, yes, it's similar to the kinds of things we've seen before, but different in other ways. And it's really good at some things and it's really bad at others. That's an important part of understanding how we're going to integrate these types of technologies in society, how we're going to set policy to control how we want that integration to how that integration should happen, and how also we can bring these technologies into our workflow and our lives to try and make things better for us. So I really want to thank the panelists for making that picture clearer. If you had a question that didn't get answered, you are literally standing between us and the coffee. So if you want to come down and speak to my colleagues, I encourage you to do so. Sorry about that. And thank you very much for your time and attention.
False advertising. The coffee's not for another panel, so you'll have to wait. Sometimes humans can lie too. So
it's literally true. It is